Alrighty guys, the next rule that we're going to learn about is called the product rule. Now product means multiplication. So we use a product rule whenever we have two functions that are being multiplied together. For instance, we have 3x minus 2 and 4x plus 5. Okay? Now the rhyme that you need to remember is it's the first times the derivative of the second plus the second times the derivative of the first. Okay? So what you're doing is you're taking the original function, f of x, and multiplying it by the second, the derivative of the second function, then adding it to the second function times the derivative of the first function. Now if you think about it with addition, it doesn't really matter then what order you do them in. If g of x and f of x get switched, it doesn't matter as long as you are adding them together in the end. So let's go through and see if this works. We're going to try this problem here. Now, before you knew the product rule, what you would have had to do is you would have had to go through and factor this. Not factor, FOIL. That would have given you 12x squared minus 8x plus 15x minus 10, which would have left you with 12x squared plus 7x minus 10. You would have taken the derivative, that would have given you 24x plus 7. That would be the derivative. Well, let's use this rule just to see what it would look like. Now, remember the rhyme is the first times the derivative of the second. The first, 3x minus 2, times the derivative of the second. What's the derivative of 4x minus 5? It'd be 4. Actually, it's plus 5. It doesn't matter. Okay? Plus the second, which is 4x minus 5, times the derivative of the first, 3. Harvard's method, that kind of looks harder. Let's see. That gives us 12x minus 8 plus 6x. See, 3 times 4, sorry, that's 12. 12x minus 15. Combine like terms. Sorry, that should have been a plus. That should have been a plus. That gives me 24x plus 7. Okay? That is how you use the product rule. And you can see we got the same thing doing it both ways. Now when it's a small function like this, that's great. But what if we're dealing with x squareds, x cubes? What happens is these start getting longer. All of a sudden starting to FOIL them takes quite a while. And the product rule ends up working out really, really nicely. In fact, the product rule is also nice if you're dealing with more than one variable. Maybe you're dealing with x, y, and z. They're all being multiplied. Just use the product rule. All right, here we go. So we've got two problems right here. Let's give them a quick try. This one, we have an e to the x to the squared. All right? So we've got the first times the derivative of the second. So that gives us f prime of x is 3x squared plus 2x times e to the x squared. Let's see, that would be ex squared times 2x plus the second e to the x squared times the derivative of the first. Derivative of the first is 6x plus 2. And you just leave it like that most of the time. It's long, it's nasty, we don't want to do anything else with it. Alright, well let's look at it now with this one. So we want to find g prime of x. Well, we know that it's the first times the derivative of the second. Sorry, just 2 variables right now. We'll do 3 maybe later this year. So we're going to do the first times the derivative of the second. So x times y prime plus y times x prime. That's it. Okay, we've got 2 problems up here. I want you to give them a try. On your mark, get set, go. All right, you should have paused the video. You should have the answer by now. Let's give them a try. So we're going to take the first times the derivative of the second. That's how we find the derivative here. So that gives us 3x to the 4th times 5x to the 4th. Okay? Plus the second, x to the 5th, okay, I'm just following the pattern, times the derivative of the first. The derivative of the first would be 3x to the 4th times the ln of 3 times the top. That would be 4x cubed. Whew. Okay. Now, if you need to simplify it a little bit, you technically could, this x to the fifth and 4x cubed would combine, they would make 4x to the eighth. But aside from that, there's really not any simplifying you can do with these. Okay. Oh, we gotta try this other one. So this other one over here, I'm gonna erase this a little bit. All right, so we're gonna take the first. So 3e to the x5 times the derivative of the second times 4x cubed plus the second, x to the fourth, times the derivative of the first. 3 e to the x5. Remember with e's, when you take the ln of e, it's 1, so we don't worry about ln's with e's. So that gives us 5x to the fourth. And again, you can combine your x's right there if you needed to. That would give you x to the eighth. But aside from that, you also could get a 12 out of that and a 15 there. So I mean, we'll simplify it a little bit. 12 ex5 x cubed 15x8 ex5. That's long.